Good afternoon. My name is Larry Tuttle, and I'm the Industrial Liaison for the Center. Let me take the next few minutes to review the key business aspects of the Center and the industrial program. First, let's review a brief history of the Center and its contributions. I'm adding to some of the things that Yogesh said this morning. As you probably know, Michigan began research into MEMS and microsystems in the 1970s. It's one of the handful of universities where much of the original research was conducted. Because of this experience, Michigan won a competitive grant from NSF, which created the WIMS Engineering Research Center in 2000. NSF funded this center with about $40 million over 10 years. Now, the WIMS Center became the WIMS II Center, which is now a self-sustaining ERC in 2010. It's an industrial membership organization, similar to many other university research centers. Through the years, the center has attracted world-class faculty and has an extensive curriculum that's well regarded by corporate recruiters. The Robert H. Lurie Nanofabrication Facility is one of the most advanced facilities in the nation. Our graduates are in high demand and find careers in the leading electronics firms. We have over 60 graduates at Apple, for example. And we have published over 1,900 conference papers and journal articles and over 80 patents, all in microsensors and microsystems. There are three components to the mission of the center, and these were established by NSF and remain essentially the same. Research, our focus is engineered microsystems. Education, both the curriculum and the research are multidisciplinary. Technology transfer, this is accomplished through both formal and informal pathways. I use this slide to describe the industrial program. We have three components: research, faculty and students, and industrial members. And three business processes: facilitate relationships, transfer technology, and administration and support. Facilitate relationships. We help connect faculty and students with representatives from member companies, and then support their engagement and collaboration. Technology transfer. Center faculty openly share the results of WIMS II research from neutrally funded sources, typically government grants. Technology transfer is accomplished through personal relationships, research reviews and reports, sponsored research, invention disclosures, licensing IP, and placing graduates. Administration and support. We organize meetings, events, invited speakers, seminars, live webcasts, site visits, help in recruiting, and we do our website. Making the business processes run smoothly is the work of our primary staff. Lynette and Teresa organize the meetings, events, and seminars. They also run our email marketing system and support the publishing of announcements, papers, and student CVs, among other things. They maintain our database of the WIMS II interest group, which has 2,500 entries, plus membership database, faculty and students, and our library of papers and patents. Rose is our artist, and you find her work in proposals and presentations and press kits, and in all the graphics in our marking pieces on the website. In February, we implemented a new suite of membership management applications, which helps us manage our industrial program. Teresa is the new web specialist, and questions about the website should be directed to her. Now, the Center's industrial program expanded last year to expand 4 corporate outreach directors. Sasan and Shaheen both are Michigan ECE grads and successful entrepreneurs and executives who see an untapped potential of the Center's technology and industry. Peru spent almost 30 years with Maxim, one of the global leaders for supplying communications, sensors, and microsystem components. Now, located in Silicon Valley, these three are using their extensive contacts and experience to help extend the Center's reach in California. Roger Grace has been a Center cheerleader for many years in writing MEMS reports and articles, in organizing MEMS trade events, and in his personal connections to the MEMS industry worldwide. These 4 directors greatly expand communicating the benefits of the Center to a much wider audience. We have a new member of our corporate outreach team. Ranjit Gupta is an independent consultant with 20 years of experience in providing engineering and business consulting to consulting services to the energy industry. He has an MS in environmental science and MBA, both from Duke. But located in Bangalore, his goal is to extend our reach to Asia, specifically in the oil and gas industry. This slide summarizes the elements of the Center's bylaws, which incidentally have changed little since the founding of the Center. The key elements are facilitated relationships, early invention disclosure, right of first refusal, and preferential IP licensing. We also expect solid feedback from the Membership Advisory Board on helping define domain requirements and set directions. I'll go over these elements with our invited guests in more detail tomorrow in our one-on-one meetings. I use this chart to summarize the business benefits that membership often provides. One major benefit is leverage university research. That's a result of greatly reduced funding of corporate research. And two benefits, often overlooked, are look forward and technology maturity. Our faculty have a pretty good idea of what research still needs to be done. And so having a relationship with a faculty member gives you an idea of what is coming next. As far as technology maturity is concerned, negative results are often not published. So having a relationship with a faculty member can tell you what probably will not work. And this can aid immensely in company planning. The WIMS 2 Center, as I said, has a new look and a new presence on the internet. Our new suite of applications is comprised of a client database, the website, and an email marketing program system. This new system requires no programming, so we all contribute to its continued enhancement. There are public areas which outline our research thrusts, leadership, faculty, and researchers, plus news, events, and several popular videos of seminars and talks. You should check it out, and on the homepage, be sure to view Ken Wise's exceptional talk on the history of MEMS called More Than More. The members-only area contain faculty and postdoc videos of recent results, plus student videos and student CVs. The advanced search engine gives public visitors to the site powerful search term access to the 1,900 WIMS 2 journal articles, conference papers, patents, books, and symposium abstracts. Now, with the new website and the university's video recording capability, we're now able to more easily record and publish presentations and seminars, both for public viewing and for members only. The members only videos report significant advances in ongoing research. Our newsletters will announce regular additions to this library of videos. Also on the members-only areas of the website, we publish videos recorded by students, reporting current results on their research areas. This site will also allow students to publish their CVs. Both of these features are a great resource for members, helping them to conduct much more effective recruiting. Now I'd like to take a little of the next few minutes and share with you some interesting notes and comments on the Internet of Things, or IoT. This graphic is a word cloud from a market research report, and note that sensors and network are near the top of the word list. Before I get into that, first I want to say that our member companies are deeply involved and committed to the Internet of Things. Here are a few examples. Note that each of our member companies has a broad set of products and services in the IoT market. And these are just a few examples I found recently. Amazon Dash is a wireless device that you attach to an appliance such as a dishwasher or a coffee maker or any appliance that uses up supplies. Press the button and the item shows up in the next day or two, possibly by drone, if the rumors are correct. Philips Hue is a set of LED lighting products for the home that can be controlled wirelessly from your smartphone. By 2020, it was reported that predicted that there will be over 100 million internet-connected wireless light bulbs in the world. Tyco's TrueView is a comprehensive portfolio of sensormatic loss prevention and retail store performance solutions. TI has a complete offering for all the components of the integrated an integrated Internet of Things solution, including cloud computing and big data. Honeywell, of course, has been in the distributed controls business since it started. In fact, they may have started it. Their Tritium product set is an application framework for building end-to-end Internet of Things solutions. And TwistThink builds innovative Internet of Things and wearables custom business solutions and has actually spun off a smart lighting startup. So, now I'm going to go through some quotes and some predictions of the Internet of Things. This quote, "The Internet of Things has the potential to change the world, just as the Internet did, and maybe even more so." This is a quote from a man named Kevin Ashton. He's a British technology pioneer who did some standards work in the RFID world. He invented the term Internet of Things in 1999 to describe a system where the Internet is connected to the physical world via ubiquitous sensors. This is another quote I like this quote. I like the author also. This guy is no relation that I know of, but I like the quote. As the next evolution of computing, the Internet of Things market will be bigger than all other computing markets. So let's take a look at some of these Internet of Things predictions. In 4 years, Cisco predicts there'll be 18 billion connected devices in industry, 12 billion in consumer and medical devices, and 6 billion smartphones worldwide. Now, McKinsey and IDC and Cisco are also making predictions, but they're predicting a thing called the economic impact. And economic impact is not gross revenues from all the vendors in the ecosystem. It's the improvement in our lives and businesses, the financial business benefits to end users in things like cost savings and improved productivity. For reference, the global GDP is about 80 trillion, and the US GDP is about 18 trillion. So this will have an enormous impact in our lives, in our economies. So this is another quote. I like this quote. It leads to my next few slides. This is a very interesting quote from Gartner Group, which is a leader in the computer industry predictions. By 2018, 50% of the Internet of Things solutions will be provided by startups, which are less than 3 years old. Most of the things that will exist in 2018, we can't even conceive of yet because they haven't been invented. Now, the Internet of Things will be driven by existing companies like our members and by startups. But let's take this opportunity to take a look at the landscape of some of the Internet of Things startups. AngelList is a site that reports where and how investments are being made in startups in scores of industries and applications. And it also provides job listings in these startups. Their site, AngelList's site, identifies over 2,000 startups in the IoT space. These are funded by a variety of sources that include crowdfunding, angel investors, venture capital firms, and syndicates. Now, greasing the skids in this arena are 300 identified incubators with an IoT focus. Just the first 2 weeks of May, AngelList added 40 new startups in the IoT space. So let's look at some of the startups just a few of them that I found in AngelList in certain areas. There are 300 startups in smart homes. One of the 300 is an application called 7 Hugs, and it's a family sleep monitor that monitors ambient conditions in your home and sleep cycles and can connect to smart lighting, radios, and other devices to help your entire family get better sleep. In the industrial world, one of these, I don't know if you can see it, it's RoboCV. And RoboC is an intelligent autopilot for wireless warehouse vehicles. It's basically robotic lift trucks. Smart cities, there are 131 startups in smart cities, where next year there'll be 23 million connected cars in the United States. Now, if you work or play in cities, the most exciting app may be smart parking. So, smart farming has 41 startups. Track a Cow, believe it or not, is a Fitbit for cows that helps farmers manage their herds. Now, wearables is a very current, hot Internet of Things application, of course. How many people in the room have an activity tracker or know someone that does? There we go. So now, to position wearables in the world of IoT, right now, another market research report identified 700 mature and startup companies in this marketplace. Fitbit was started in 2007, so it's a very recent, very fast-growing, very large market space. So my takeaway from all of this is from tracking cows to finding parking spaces. The Internet of Things is predicted to be the next big thing, and because of this, our world will be incredibly different in 10 years. And probably unimaginable in 20 years. Wide use of the Internet itself is barely 20 years old. So the purpose of the past few slides was to provide the background for what I like to do in positioning university research and the WIMS 2 Center in this new and exciting IoT ecosystem. This is the value chain I found on the Internet for the IoT ecosystem. Now, when I worked at IBM and HP and DEC and a couple of small software companies, we used to say that everybody in the IT industry, we were all just value-added resellers of sand. I mean, think about it. That's what this chart shows. As you build toward a business solution for an end user, each member of the value chain takes the output of the previous member and adds value to it. This starts with sand or silica, which I guess that's where we get the silicon for chips from, and ends with a business solution for a client. I think we need to add a segment to this chart. So the original source for technology that ends up in chips is very often government-funded university research. Last fall, I showed that every major technology breakthrough that Apple integrated in the iPhone came from previous university research. I would like to add university research to the IoT value chain. Now, WIMS 2 technology and application thrusts fit perfectly in the value chain for the Internet of Things. Though not a commercial product, the built environment thrust bridge monitoring system is actually far along the value chain because it provides a completely deployed end-to-end Internet of Things solution: devices, networks, data, analysis, and user interface. Now, I would like to see the future value chain graphics show that university research, and particularly the WIMS 2 research, become an integral component of the IoT value chain. One can say that university research initiates the value chain for the Internet of Things. With that, thank you for listening. Mark the week of September 19th, 2016. That's the fall 2016 Research Review and Industrial Advisory Board meeting that will be held that week. Thanks a lot. Are there any questions?